This section is on angles and their measure. You're going to find how to measure an angle, convert between degrees and decimals, or degrees in decimals and degrees, minutes, and seconds, and convert between degrees and radians. So Ray, you don't have to put this in your notes. It's just a little background information. Array, it has an endpoint and then it goes on forever through another point. Should learn that in geometry. It's kind of like a laser pointer. An angle consists of two rays with a common endpoint. That common endpoint is called the vertex. So the common endpoint is called the vertex. The sides are the two rays coming from the vertex. So that is an angle. We have a vertex and the two sides, which are rays coming from that common endpoint. Degree is the measurement of an angle. The symbol is this little superscript, looks like a little circle or zero. There are 360 degrees in a circle. Put that in your notes. You need to put that in your notes. That degree is measurement of angle. Straight line has a measurement of 180 degrees. And you can divide up degrees. Degrees is actually a pretty large measurement. In every degree, there is there are 60 minutes in 1 degree, and there are 60 seconds in 1 minute. Some other vocabulary on the coordinate plane. If you're going to put an angle in standard position, the vertex is on the origin and the initial side lies on the positive x-axis. So here, the initial side we have on the positive x-axis, and the vertex is at the origin. Remember, the coordinate plane divides a quadrant into divides the plane into 4 quadrants. You have the first quadrant, second quadrant, third quadrant, and fourth quadrant. If I have an angle, I can have an angle in any of those 4 quadrants, but I also can have an angle on the axis itself. Those are called quadrantial angles. Quadrantial angles. So when you have an angle on the axis itself, it's called a quadrantial angle. Well, if you're going to have an angle and it's anywhere between 0 and 360, that's fine, but you can have angles bigger than 360 and you can have negative angles. Well, you can have what's called coterminal angles. Well, coterminal angles, the measures differ by multiples of 360, either positive or negative. So to generate a coterminal angle, you either add or subtract multiples of 360. And that will get you different angles. It looks the same when you draw it on the coordinate plane, but they're actually different angles. So the measure of an angle is determined by the starting from the initial side. So the initial side is where you start. The where you end is called the terminal side. So some more vocabulary you need to know. If you have a positive measure, you're going clockwise. So if you're on the coordinate plane and you have it in standard position, so here is my ray of the initial side, and I go the positive direction to the terminal side. So that is a positive angle. A negative angle goes counterclockwise. So here's my initial side, and I go counterclockwise to go to my angle. That would be a negative angle. It's clockwise. So here are the quadrantial angles. Well, either the positive quadrantial angles, if I'm going counterclockwise the normal way, so that's 90, 180, 180, 270, and then back to 360. And the negative quadrantial angles, so has negative 90, negative 180, negative 270, negative 360. You can have different angles have different names. You have a right angle. A right angle is an angle measuring 90 degrees. You have an acute angle, which is less than 90 degrees. Obtuse is between 90 and 180 degrees, and a straight angle is 180 degrees. So let's find some coterminal angles of these two angles. So I have 45 degrees. So to find a positive coterminal angle, we add multiples of 360. So I'm just going to add 360, but you can add 720 or so forth. So you can, or 1080, just whatever multiple of 360. I'm just going to add 360 to make my positive coterminal angle. So 45 degrees plus 360 is 405 degrees. And then if I want to find, so 405 degrees and 45 degrees, if I would graph them, look exactly the same, except for you're going around the circle. So that is a coterminal angle. And I can subtract 360, it's another coterminal angle. So 45 degrees minus 360 is 315 degrees. I'm sorry, negative 315 degrees. So that is a negative coterminal angle. Well, negative 36 degrees, once again, I can add 360. So negative 36 degrees plus 360 will give me a positive coterminal, and that's going to be 324 degrees. Or I could subtract 360, so negative 36 degrees minus 360 is negative 396 degrees. So those are coterminal angles. You just add or subtract multiples of 360 to find coterminal angles. So let's sketch this angle. Now, when I say sketch these angles, I'm not looking for exactly getting a protractor out and tell me exactly where it is. When I say sketch it, you put it in the correct quadrant. So here at 35 degrees, I know 35 degrees is between 0 and 90 degrees, so I know it's somewhere in quadrant 1. Okay, I don't have to make an exact 35-degree angle, just make an angle in 35 in the first quadrant, and then just say that it is 35 degrees. Notice I have my initial side here on the positive x-axis, and then I go up to my terminal side is in the first quadrant somewhere. That's 35 degrees. And I know that is in quadrant 1. Negative 159 degrees. Well, negative means I have to go counterclockwise. Well, this is 0, this is 90, and this is 180. I'm sorry, negative 90 and negative 180. So negative 90 and negative 180. And I know that a negative 159 is between negative 90 and negative 180. So I know it's somewhere in here. So my negative 159 degrees, remember I'm going clockwise, sorry, I'm going clockwise, and that is negative 159. My initial side is on the positive x-axis, and my terminal side is somewhere in the third quadrant. So 512 degrees. Well, we have angles that only go from 0 to 360. So I need to find its coterminal angle first. So I'm going to subtract 360 from it. And when I subtract 360, so 512 minus 360 is 152 degrees. So 152 degrees, if I were to find out what quadrant that is, well, that's 0, that's 90, this is 180, so it's somewhere between 90 and 180, so I know it's somewhere in this quadrant. So I know it's in quadrant 2. So since it's in quadrant 2, then this is actually 152. If you want 512, well, 512, you go past it and back to it. That is 512 degrees. You see the difference between 152 degrees and 512? They're coterminal. They have the same position in that quadrant, but the coterminal angle goes in the goes around and through the angle and back to it. Okay, because you subtract 360. So that is a coterminal angle. (270). Well, 270, it's one of the quadrantial angles. So here's my initial position. Here is 270. So that's 270 degrees. And it's not in a quadrant. It's actually a quadrantial angle. It's quadrantial, and it's on the y-axis. Radian measure. Radian measure is another way to measure angles. We have degrees, and you're familiar with degrees. You've seen them before, but we also have radian measure. Radian measure is a little bit different. Radian measure has to do with the length of the radius and the length of what's called the arc. Okay, it's part of that circumference. Well, the way the radian measure works, the circumference is 2 times pi times the radius. That's circumference. So if my radius is r, or if my radius is 1, then if I go all the way around the circle, is actually going to be 2 pi. So radian measure is in terms of pi. So if I, instead of 360, 360 is 2 pi. So if we're converting between degrees and radians, the conversion factor is pi over 180. Because if I go back, if going around the circle is 2 pi, going halfway around the circle, if I go halfway around the circle, that's 180 would equal 2 pi. Because all the way around the circle is 2 pi. So halfway is pi. So that's why pi over 180, well, pi is your radian measure, 180 is your degree measure. And if you have taken chemistry, if you remember the railroad track method in doing conversions, well, your conversion factor is pi over 180, or 180 over pi. That converts between radian and degrees. So here, the pi over 180, or 180 over pi, is actually 1. It's your conversion factor. So here we have a bunch of degrees. And when you're converting degrees into radian, you're going to be multiplying by pi over 180. Now, yes, you could plug it in your calculator and you get a decimal approximation. But in radians, you like to have it in terms of pi. So what you want to try to do is always, if it's nice numbers where you can reduce the fraction, reduce the fraction. So you have fractional pi. So some fraction of pi. So you always want that with all your radians. Now, sometimes that isn't possible, and then you do have to find a decimal approximation. But if you can, these are some of your nicer angles. You can reduce it and have a fraction of pi. For instance, 30 degrees. Well, 30 degrees, if I multiply pi over 180, well, 30 goes into 180 6 times, so it's pi over 6. You just reduce the fraction. For letter B, 120 degrees, well, multiply that pi over 180. 120, well, 60 goes into both of them. 60 goes into 120 2 times, and 60 goes into 180 3 times. So you have 2/3 pi. So it's fractions of pi. Negative 60 degrees, well, if it's negative, it stays negative. multiplied by pi over 180. Well, 60 goes 183 times, so you have negative pi over 3. And then 270. 270 divided by pi over 180. 90 goes into both of them. 90 goes into 273 times, and 90 goes into 182 times. So you get 3 pi over 2. So all those were very, very nice that you can reduce the fractions into nice fractions. This next one with e, when I do that, it doesn't, yeah, they're both even. You can get sort of a fraction, but it's not one of these nice fractions. So in this case, I go ahead and I just plug this in the calculator. 104 times pi divided by 180, and you get a decimal approximation. So unless it makes a nice, if you can reduce it nicely, then reduce it. If not, then use the calculator. So now I'm going from radian measure to degrees. Well, I have pi on top, so I get rid of pi on top. I need pi on the bottom. So now the pi's cancel out. And 180 divided by 3 is 60. And negative pi over 2, once again, I multiply by 180 over pi. The pi's cancel out. And that 180 divided by 2 is 90. It's negative 90 degrees. 5 pi over 6, once again, I multiply it by 180 over pi. The pi's cancel out. Well, here I can do my multiplication, 5 times 180 divided by 6, or you can think that 6 goes in 180 30 times, and 30 times 5 is 150. Either way. Now letter D, well, letter D doesn't have a pi in it. So since D does not have a pi, I just need to put it in the calculator exactly the way it is. 5 times 180 divided by pi, and you get 286.48 degrees. So you get a decimal approximation of the degree. Now, you need to learn these special right triangles. We're going to be using them for a long, long time. So from the end of this semester and even into January and February, we are going to be using these triangles. So you need to memorize these triangles. So you have a 30, 60, 90 triangle. Now the way I remember a 30, 60, 90 triangle is 1, 2, square root of 3. 1 is always across from the 90. 2 is always the hypotenuse, and square root of 3 is what's left. That's your 30, 60, 90 triangle. You also need to know it in your radian form. So 30 degrees is pi over 6, and 60 degrees is pi over 3. Now, a lot of people mix those up. But remember, the bigger denominator, the smaller the number. So pi over 6 is 30 degrees, pi over 3 is 60 degrees. And then you have your 45, 45, 90 triangle. The way I remember 45, 45, 90 triangle is 1, 1, square root of 2. So the legs are 1, and the radius, or the hypotenuse, is square root of 2. So here, the 1, 1, square root of 2, since I have pi over 4 is 45 degrees, you got to know that also. So you have your 30, 60, 90. Your 30 degrees is pi over 6, 60 degrees is pi over 3, and 45 degrees is pi over 4. You got to know those. You're going to see those over and over and over again. So you got to memorize these two triangles. They should have been introduced to you in geometry. So here are all the angles around the circle that you can form using your special triangles. So there's all your angles. So you have them in degrees, and most people in the beginning understand how to find degrees and which quadrant they're in, easy enough. It's the radian measure that a lot of people have difficulty with because it's new. So I want to help you figure out how to find out without a lot of thinking on where each angle is on this circle. So if I have a pi over some number, I'm in the first quadrant. So if I have pi over some number, I know I'm in the first quadrant. If I have 1 less than the denominator, if the numerator is 1 less than the denominator, I'm in the second quadrant. So in radian degrees, if the numerator is 1 less than the denominator, I'm in the second quadrant. And if the numerator is 1 more than the denominator, then I'm in the third quadrant. And if the numerator is 1 less than twice the denominator, I'm in the fourth quadrant. Now, if you have a radian measure where the numerator is more than twice the denominator, you got to find the coterminal angle that is less than 2 pi. So you got to find the coterminal angle first, and then you go through the whole process we did before. So that's for positive angles. Now here I have the same circle. I have the positive angles that you saw before, but you can also do it in the negative angles, but everything is reversed. So the fourth quadrant is pi over the denominator. The third quadrant is 1 less than the denominator. The second quadrant is 1 more than the denominator. And the first quadrant is 1 less than twice the denominator. So it's just backwards going around the circle the negative direction. If you're having difficulty with that, you can always change a negative angle to a coterminal angle that is positive and just learn it that way.